So is my screen shared with you?
Yes. Okay. Yep.
All right. So we were talking about the evaluation, and very quick we will revise the previous
Uh-huh.
sections also.
Uh-huh.
So what evaluation is the process of understanding the reliability of any AI model based on outputs by feeding test dataset onto the model. So actually it's the difference between actual and predicting one. Then we will be discussing about confusion matrix, accuracy, precision, recall, and F1 square. So what's the confusion metric over here? That is the result comparison between the prediction and the reality. So it can be recorded in we call confusion matrix, and confusion matrix allow us to understand the prediction result. So it can be understand that the difference between true positive and the false positive, and false negative and true positive. So true positive and false positive, similarly false negative and true negative. So this is the on the y-axis we are having prediction, and on the x-axis we are having reality. And if it is true, if it is no, it is yes, it is no. So we can have that true positive prediction reality, and then true negative, then false positive and the false negative, vice versa. So these are the real example over there. If we are having actual fire on the ground and actual reality, and my model is also predicting that event correctly, so I will say that condition true positive.
Uh-huh.
In the reverse order, if my prediction is saying no and reality is also saying in the negative pattern, then I will say it is true negatives.
Uh-huh.
So in the both cases my system is predicting correct. So now my system is predicting correct, but reality is not there. So in that case it will represent as false positive.
False positive. Yep.
Similarly the vice versa is also possible. So using these two attributes we can have the confusion matrix also. So here we are having that setosa, that is the x-axis we are having reality, and along the y-axis we are having prediction part. So my system is going to predict setosa as a virginica no. Similarly that 6 is going to define as the this one. This 6 is going to define something. So my reality is no, and
Uh-huh.
prediction is yes. So it is false positive, yes or no?
Yes.
Yes. So this is false positive. My prediction is saying yes, but my this one reality is saying no.
Yeah.
Similarly, on the right hand side, we are having large error on the system, and more number of parameters are also here. So we can have the 5 cross 5 matrix upon the confusion matrix.
Uh-huh.
Coming back to the accuracy, we can have the accuracy is defined as the percentage of correct predictions. So how many correct predictions are there, how many total cases are there. We are more focusing on true positive and true negative, how much time my system is going to predict correctly. So that is the numerator, and the denominator representing the all the training part. So this is accuracy. Now
Uh-huh.
again discuss means limitation part. So moving ahead, the model is not going to predict anything positively. True positive is
Yeah.
none. So in that case my system is no use for me. Suppose I am predicting landslide and it is not predicting even a single time, but although it occurred in reality. So I will say that okay, my system is going to waste my money, entire dollar is going to be wasted.
Mm-hmm.
So there is no use of that 98% of perfection or the. So now precision is defined at the percentage of true positive, because we are going to focus on that true positive where prediction is true and reality is also true. So we are having that precision out of the true positive and false positive. Then limitation, going back to the forest fire example, we are having few limitations over there. I am skipping this part, coming back to the recall. It is true positive only and the true positive plus false negative. So difference between recall and precision is it is going to have true positive in the numerator. It is having also true positive on the numerator part, but in the denominator that was having true positive and true negative, but here we are having true positive but false negative.
Okay, if we have false negative instead of false positive. Okay, precision has false positive. This one has false negative.
Yes.
Okay. And accuracy, that's defined as true positive plus true negative, right?
Yes.
Over true positive, true negative, false positive,
Yes.
everything, all four sections.
Yes.
Okay, that makes sense. Okay.
So
Okay.
we can have that how much time my system is going to predict correctly. So that is the accuracy. But sometimes we don't
Yeah.
need that accuracy. We need the precision, because what's the
Yeah.
accuracy means I'm so mechanical people understand this. People sometimes we understand this this the in the mechanics also, that if somewhere I am having that nut bolt, and this nut bolt
Mm-hmm.
is screw also, so this screw is going to here I am having cycle on the round side, and this
Mm-hmm.
screw is going to fit on this nut bolt. So
Mm-hmm.
so so this is having 2 centimeter as a diameter, so that is the accuracy, but still this nut is not going to fix on the bolt. That is the precision part, because it is not very much precisely developed or manufactured so that it can be round upon the nut bolt. I can roll up on this nut bolt, what would I say. So that is the precision part, so it should precise by 2.113 centimeter itself. So
Mm-hmm.
I'm going to focus true positive and with respect to true positive and false positive. So how much time my prediction is going to true, that is the precision.
Okay.
But how much time false negative and then true positive, how much time reality is going to true, that is the denominator over here. So recall, yeah, we can also recall in such a way that recall is going to correlate with the reality, whereas the precision is going to correlate with this one, prediction.
Mm.
So these are the buzzword we can easily correlated with each other. So this is, I think this is the coincidence, not the deliberate attempt, but the coincidence that they are having these synonyms.
Got it. Prediction and reality. Okay.
Alright. So now we have noticed that we can see the numerator in both procedure is same, true positives, but in the denominator precision counts the false positive, while recall takes false negative into consideration.
Yes.
So which is better? We also discuss upon that. Do you want me to explain once again?
No, it depends on the situation,
Exactly.
right?
It
How
depends on
severity of the
yes,
situation.
case study for which I am going to develop that
Uh-huh.
this model. So again,
Yes.
case with high false positive cost, case with high false negative cost,
Uh-huh.
and what's that? So here are the few examples: forest fire, viral means COVID-19. We can say that, then spam and mining.
So, okay, so let me think about this. So the case with the high false negative cost. Okay, so forest fire versus viral false negative. Um, Meaning that the prediction was true, but the actual was no, it was false. Um, so in this situation, it says which one is more important, recall or precision? So in this, we need to know the recall, right? Are we looking at it like that? So forest fire,
So most of the time,
false negative.
so in the training
Mhm.
part, most of the time forest fire will be in yes format or no format.
Mhm. Yes or no, right? So
No, so
false
see,
negative
most of
would
the
be
cases it will have which class, yes or no. Most
for this one false. This one will no.
no, because most of the times in generally we talk about forest doesn't have fire, so we would say that
Mhm.
the prediction means the reality will say for means reality will say yes, but prediction is saying no. So cost with high
Yeah.
false negative cost. So in the when we are having high fn, so that uh, f means what was that? I just forgot. Recall.
Mhm.
So in that case, recall will have that false positive term, so it will have false negative term,
Mhm.
but the precision will have that in the denominator, that true positive.
True.
Okay, let me see it again. Yes, it is having false negative, true positive, false positive. This is false positive, and this is true positive, and this is true positive. So now this false negative is high, so recall will be low. Is that true? If in the
Recall would be low, meaning recall was prediction, right?
yes,
Um, Sorry, I'm just trying to wrap my recall would be the reality. So if so if our forest fire is high, yeah, recall will be low.
because it's coming into the
Yep.
denominator, so when it will
Yep.
increase, so be recall will decrease.
Mhm.
So I will have that so similarly in the precision I don't have that f negative part, so
Mhm.
it would be in a different case in precision.
Okay. So in this situation, they're saying that which one is more important, right?
Yes.
So okay,
So false negative says reality is yes, but prediction is no. So false
okay,
negative is very means if someone is having false negative, so that is very costly. That will cost a lot.
yes,
If
especially
reality,
with the fire. Yeah.
yes. So if reality is no and prediction is yes, so spam, like in reality it is not spam, but if the prediction saying that okay yes it is spam, or when we talk about the mining, in the reality it is saying no, there is no
Hmm.
no means valuable things, and
Hmm.
in the prediction it is saying yes it is
Yes.
there, so that will cost a lot.
Okay.
Alright.
Okay. Okay. False
Okay, so coming ahead, we are having f1 square score is equal to 2 asterisk precision and recall precision recall. Also, f1 square can be defined as the measure of balance between two terms, buzzwords. So, an ideal situation would be when we have a value of 1, that is 100% for both. In that case, f1 score would also be ideal 100. It is known as the perfect value for f1 square. So as the values of both range 0 to 1, f1 also range from 0 to 1.
Hmm. So F1 is it's a kind of balance between the two. Okay.
Yes.
Mhm.
So balance method precision is low, recall
Uh-huh.
is low. So in that case, f1 score will be low, and when precision is low and recall is high, so f1 score would be low. Also, when both is high, then only it will have high. So it is using this formula simply.
If the precision is low, recall is high. F1 score will be low. Okay. If the precision, how are they even making sense of F1 score? How they're saying that it's going if it's low and high, it's going to be low.
By putting some values over here, can we
Okay, okay,
can we
okay.
have some values inside this function, inside this
Uh,
formula, so we can have that impact over there.
okay, got it. Okay, I thought it was
Yes. So
thinking one. Okay.
similarly we can have predicting ground earth positive negative, and that is the recall. So when we going this value means towards
Uh-huh.
this side, we will get recall formula that is involving true positive and false negative. So when we will moving towards this along the x-axis, we will be obtaining true positive and false positive involving these two terms. So, but
Okay.
accuracy is combining whole matrix, 2 cross 2 matrix.
Yep. Okay.
Is that clear?
Yep. It's making sense.
Yes. So accuracy. So they have given some example over here. So
Mm-hmm.
if precision is 0.67 and recall is 0.318 over here, so then we can say
Mm-hmm.
that this one is this value will be like this. And then we can assume that if 0.318 instead of 0.318, if we will have that 0.98 something, so obviously this value will decrease, because the numerator is also increasing and denominator is also increasing, but because of denominator we are going to decrease that value.
Okay, so if sorry, hold on. So if you're saying okay, so we have the accuracy of zero point 0.7,
Yes.
right? So we want to higher the accuracy, better our prediction is, right? So if accuracy is 0.70 and then recall is zero point 0.6, I'm sorry, precision is zero point 0.6, recall is 0.3,
Mm-hmm.
F1 score is 0.4. What conclusion can we draw from there? It is less than.
So 2 asterisk 0.647 multiply 3.18 upon 2647, 0.318 is equal to 426. So let's calculate on
Mhm.
Google. So it is 2 asterisk 0.647 asterisk 0.318, then divide 0.647 plus 0.318 is equal to 0.426. Okay, so let me change that value of second term. So that is 9, let's say, and that is 9 again.
Mhm.
So this is increasing.
Right.
So if I am having zero point 0.9 value, so that is this is also increasing.
Okay.
Similarly, if I will increase that value 0.12, okay, I am increasing this value to 0.9, 0.9. So this
It's
value,
closer to one. Yeah.
yes, so this will have that 9 approximate zero point 0.9. All right, so they are saying that,
Mhm.
yes, here, so if value will high and then value will high, recall value will high, so then only
Mhm.
it will have the higher value. But
Yes.
if we low the value and any of these value will have the low factor, then it will
Mhm.
have the low on the right hand side.
Mhm.
Is that clear?
Yeah. So what I'm question is with that 0.42, F1 score is the balance between the two, right?
Yes.
So in mathematically, so if you need to draw a conclusion from our data, right, we
Mm-hmm.
can say that our F1 score is low,
Mm-hmm.
right, because our um, prediction and reality is low.
So they are going to have that prediction recall is going to means involve false negative, but it is going to involve false positive. So they are
Mhm.
going to means impact over the overall impact of the system, and what's the output over there. So they will have
Okay.
the cumulative value of that model.
Mm-hmm.
So
Mm-hmm.
not the recall is involving too much, not the function. So what is the median value of that?
Okay.
So they are going to find that value. So uh, so they are saying, okay, we are not considering that precision alone, we are not considering
Mm-hmm.
recall again. I want to the means median value of these two. So for that they are having f1 score, but they are also stating that if you want to have that more f1 square, in that case we need high precision and high recall both.
Mm. To be more accurate.
Exactly.
Okay, that's what I was asking. Okay.
But also reciprocally I should say the false positive and the false negative values should be lower in that case, because both are coming in the denominator in the formula
Mm.
of reality, the recall and precision respectively.
Okay. Yeah. Okay. So that makes sense. Okay. So that's
S-
accuracy.
yes, so if we extend the same logic to calculate the precision and recall the each class individually, so we are having that function, and then we calculate the f1 score individually. So we will calculate the f1 score individually. What do we mean by why we are calculating f1 score individually?
Individually, because there are three different categories,
Yes, but
right?
here
So we.
we had only means let's say one category is there and one category is there, so we are having that precision. So what does it mean that individually? How would we calculate? So what would be the formula to
Oh,
calculate the
okay.
individual
So
one?
yeah. So it'll be yeah. True. Cat, catfish, and cat hen, right?
Hmm.
So no, it'll be first one will be cat to cat, and then fish to cat, and then hen to cat,
Yes.
and then move on to cat to fish, and then okay. So okay. So okay. Literally. Yep.
So precision for the cat is 30.8% and recall is 66.7%. But how we are
Mm-hmm.
obtaining this 30.8%? That's the question here.
The formula for precision was the hold on, I had true positive. So the true positive over true positive plus false positive, right? Times 100. So we'll take the true positive number, which for the cat, I don't know what I have that. So cat to cat, that's our true positive.
Yes.
Divide by true positive. So yeah, let me see this one. There you go. So before divided by 4 plus
4 divide by
4 plus false positive.
false positive,
A false positive was 6.
then 3 also.
Yep, and then plus 3.
So 4 upon 13. So
Yep.
let me check on my
What does that give you?
4
13%.
divide by 13. Yes, it is 30.769. I'm using my mobile phone calculator.
Okay.
So it is giving 0.307692 something. So that is approximate 30.8. So that's correct. We have
Yep.
deployed the formula correctly. So
Okay.
now similarly we are calculating recall and F1 score also.
Mm-hmm.
So we will have that cat is having, means hen is having better F1 score.
We're saying that hen is having a yes, hen is having a better F1
Yes.
score. Okay. Okay. Let me
So
take
more example over here, cat predicting actual one. So this one. So he used to ask so many questions from this matrix. I can recall that which matrix is going to define the perfect model. So means the confusion metric is like this. So the first metric saying that prediction is yes and the actual is also yes. So that is 50. But false
mm-hmm.
positive. So we are having prediction is yes and no is yes. So is this a good model, suitable model? First matrix.
Is it a good model? So let me see. True positive, and you have true false positive, and then F1 score.
True positive is 50 and 0. False positive is again, false positive is, true positive is 0. So that is 50
Yeah,
and 0 plus 50. False positive is 50 again. So precision is 1.
that's good.
Alright, but when we talk about the recall, so recall is equal to
Uh-huh.
true positive upon true positive plus false negative. So
Uh-huh.
so true positive is 50, first is upon 50 plus false negative is 0.
Uh-huh.
So that is again 1. So when we have f1 score,
Mm.
that is 2 times 1 multiplied by 1. So is that plus multiplication, 2 times 1 divide by 1 plus 2, 1 plus 1. So f1 score is also 1. So this is the perfect model, I would say.
Yep.
First one. So second one is also, second one will have very poor model because true positive is 0. So it will give precision 0 and recall 0, both
Mm.
0, and f1 score will also 0.
Okay. Yep. So yeah. So closer to one, it's that.
Yes. So then
Yeah.
what is next? Okay, I think nothing left here. It ends the PPT. Yes, that's it. Okay, so
Mhm.
what next?
We can jump into case study. Let me see what else do I have. Okay, we did the F1. Yeah, I think we can do hypothesis testing. I think we did that. Hypothesis test.
All right.
Yeah, I understand. Yeah, that's pretty basic statistics. The mean, um,
New folder and screenshot.
null hypothesis. I understand that.
Okay, so
When do we reject the funds?
that that regression or prediction binder,
Mm-hmm.
binder 1.
So this one, actually, if we can, how much time we have? 12 hours. So it's whenever you want to. So yeah, the first one that we have is hypothesis testing. Do you have that
Mm,
in
I
mind?
am having hypothesis case study. So,
Yeah, okay, let's do that.
and that is the code
Challenge.
challenge. Okay,
Sure, yeah.
we should go with the code or that PDF file.
Um, Let me look at the. I think I read on my own.
Mm-hmm.
So if I have any questions, I think I can answer. So let's go